In this lesson, we're going to be graphing absolute value equations. So remember that absolute value of a number is its distance from 0. So now we're going to be graphing a whole bunch of possible numbers and their distance from 0. So first thing to do, if you don't know what a graph looks like, is always just make a table. So let's pick some random x values, maybe -3, -2, -1, 0, 1, 2, and 3. And let's just see what happens. So if we plug in -3, well, we're going to get the absolute value of -3. So absolute value of -3, and that's just going to be 3. If we plug in -2, we get the absolute value of -2, that's 2. This is 1. Absolute value of 0 is 0, 1, 2, and 3. So let's plot these points. We've got the point 0, 0, 1, 1, 2, 2, 3, 3. We've got -1, 1, -2, 2, -3, 3, and so on and so forth. And you can see that the pattern would continue on up this way and up this way. So if we look carefully at this graph, if we look at just the right half of it, so starting here at the vertex, so this bottom point is called the vertex, starting up at the vertex and going up this way, that just looks like the line y equals x. In fact, the line y equals x would look like this. So slope of 1, y-intercept of 1, let me actually redraw that, I got off a little bit. So it goes straight through diagonally here. That's the line y equals x. So if we're looking at the absolute value of x, think about absolute value, again, distance from 0, or it makes the number positive. So basically what we've done is we've taken this part down here that had negative y values and flipped it up here to give them positive y values. And so that gives us this V shape. It gives us this cusp, this vertex at 0. So the right half of the graph is really just the line y equals x. The left half of the graph is really just the line y equals x, but reflected up so that we have the negative numbers becoming positive. If we look at the absolute value of x minus 2, this is really just going to take the absolute value of x, the one we just graphed, and take the whole thing and drop it down 2. So actually what I'm going to graph first is I'm going to graph y equals the absolute value of x, what we just graphed in the last one. So that looks like this, and then I'll graph this with this color. So let's again make a table, just see what happens. So again, I'll just take the same values, and then let's just see what happens when we plug this in. So there's what you get. And if you might want to check those just to make sure you understand how to plug those in, but those are the y values you get for those x values. So let's plot those. There they are. So we can now graph this, and it's going to look just like this. Now if you look carefully at this and compare it to the parent function, you'll notice that every single point on this graph is shifted down 2 from the parent function, and that's what this -2 does. So it takes the absolute value of x and just drops it down 2. So the vertex here drops down 2, this point right here drops down 2, this point right here down 2, this point right here down 2. Everything on this graph is just exactly the same as the other graph, but just shifted down 2. It just drops the whole graph down 2. So that's what this does out here. If you have something minus or plus after the absolute value, it's going to shift the graph up or down. Well, what if we have something like this? If we have the -2 inside the absolute value? Well, this is going to do something else. Again, if you don't know what the graph looks like, just make a table. Pick some random values and see what happens. So I'll pick all the same values as we had last time. So there's all the points with their corresponding y values. So now what we want to do is take all those points and graph them. Looking at these points graphed, you can tell that the V, the cusp of the V, or the vertex, is shifted over a little bit. So maybe we want to get a few more x values to the right. So maybe let's plug in 4. Well, 4 minus 2 is 2. Absolute value of 2 is 2, so that's the point 4, 2 right here. And we could keep going. We would get 5, 3 and 6, 4. You're welcome to check all those if you would like. But basically what's going to happen is we still have this exact same V, but it's shifted over to the right. And so this is what that minus 2, or I should underline just this. So the minus 2 there, if it's inside the absolute value, if it's right next to the x value, it's going to affect the x coordinates of the entire graph. So it takes that v and shifts it to the right 2. Now you want to be careful here. If we look back at the last one, this one had minus 2 and it shifted it down just like you might expect because, you know, minus is down, up is positive. But on this one, there we go, it's a little bit different. So it's flipped the wrong way. So you would think that a minus 2 would shift it to the left, but it doesn't. It shifts it to the right. So the way that I kind of like to think about this is if you think about what would give you the 0 under the absolute value. So in order to make that happen, we need to have a positive 2 in there for x. So 2 minus 2 is going to give you 0. And so that's going to tell you that it'll shift it 2 over in the positive direction. Every x value needs to be shifted over 2 in the positive direction to get the same y values. So that's what that one does. Now let's look at doing them together. So if we have both of these together, again, we could just make a table and graph, but let's see if we can figure this out. So this plus 1 is going to shift the graph either left or right. So we got to figure out which way it's going to shift it. Well, remember in this one, if we have a minus 2, that shifts it to the right. So a plus 1 should shift it to the left, and that's what it's going to do. So it's going to take, it's good to think of the vertex here. It's going to take that vertex and shift it to the left one. I mean, it does shift the whole graph to the left one, but it's good to think of the vertex. Then this plus 2 over here is going to shift the entire graph up 2. So the vertex, if we think it would normally be at 0, 0, it's going to go to the left 1, and it's going to go up 2. So this is where the vertex is. And now we could just kind of think about how the graph looks. So if we look back at, say, this one, you'll notice that the slope of this line is up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and so on and so forth. The other side is the slope of negative 1, down 1 to the right 1. And so let's do that over here. So we're going to go up 1 to the right 1, up 1 to the right 1, and then for the other side, go up 1 and to the left 1. Just do the mirror image. And we're going to get a V that looks like this. So that is kind of the quick and easy way of graphing the absolute value. If you know what the shifts do, you can just go ahead and do those right away and graph it. You don't have to worry about making a table. A table, of course, will work, but it's a bit more work than that. All right, let's do another one of these. So if we have plus 4 inside the absolute value, that's going to shift the vertex from what would normally be the point 0, 0. It's going to shift it to the right 4. The minus 3 at the end, that'll take the whole graph and shift it down 3. So remember the x shift, the horizontal shift, goes the opposite way you'd think it would. You'd think plus 4 would, oh, I just did that wrong, actually. It's going to shift to the left 4. So you would think it would shift it to the right 4, but it's going to shift it to the left 4. And then minus 3 is going to shift it down 3. So the vertex will be right there. And then again, we could look at the slope. So the slope is going to be positive 1 for the right side, negative 1 for the left side. And so we get this V here. One last thing that can happen with these, and that's going to be that the slope of those lines can actually change. So the slope does not necessarily have to be 1 and negative 1. It can be other things. So if we look at having a number outside front, think of this as being like y equals 2x. It's going to be much like the line y equals 2x, which I will draw real quick here. So that is the line y equals 2x. It's going to be pretty much exactly like that, except the absolute value is going to take this part down here that's negative and flip it up and make it positive. But again, we could just make a table. So we could say, let's say x and y here, and we could plug in maybe negative 2, negative 1, 0, 1, 2. And if we plug in negative 2, we're going to get absolute value of negative 2, which is 2, then times 2 gives you 4. So negative 2, 4, that's this point right here. And we could go through and do all these, and they would line up. You would get negative 1, 2, 0, 0, 1, 2, and 2, 2, 4. And they would line up. But the point here again is that this 2 out front will change the slope so that on the right side you get a slope of positive 2. On the left side, where the absolute value is taking effect, you're going to have a negative slope. So if the slope is negative, it's it's good to think of, I mean, you can definitely think of this as the slope, but you want to think of it as the slope of the right half. And then the left half is going to be opposite that. So this graph is going to have a slope of -3 on the right side. So there's no shifts in here. There's no x plus or minus something. There's nothing afterwards that's going to shift it up or down. So the vertex will be at 0, 0. But then from here, we can use this slope to find some more points. So it's the slope of -3. It may help to think of that as -3 over 1. So that's going to be down 3 to the right 1, down 3 to the right 1. And then we can get the right half of the graph by doing that. The left half of the graph is just going to be the mirror image. If we think about the vertex having a mirror going through it, it's just the mirror image. Or it's just take the slope and switch the sign of it. So this side is going to have a positive slope. So it'll look like this. So an important thing to mention here is, here when we have a positive slope, there's a slope of +2, the v is going to open upwards. If we have a negative in front, that's going to give the right side a negative slope, and so that's going to make the v open downwards.